Hey guys, so this is going to be the first video for chapter 9. So in the last chapter, we talked about experimental designs, specifically between subjects design. And so now we're going to talk about within subjects design. Um, you can read through this. I'm not really sure if it's really going to prompt you guys to think about the things that I want you guys thinking about for this first section. It's more for the later sections, but it is the first slide, so we may come back to that though. So here are your chapter objectives for chapter 9. There's 8 this time, and so here is the first 5, and here are the last 3. And again, those are in your chapter. Okay, so the first section, we're going to talk about introducing what within subjects experiments are, and the characteristics of those. And so that's the first learning objective of your chapter. And then the second learning objective, so we're talking about learning objectives 1 and 2 here. The second one is about these threats, especially time-related threats to internal validity. Specifically, there's 5 of those: history, maturation, instrumentation, order effects, and then, oh my goodness, my paper just, I just lost my paper. And then statistical regression. And so those are time-related threats to internal validity. And you might be wondering why we're talking about time suddenly now. And because that is with the structure of a within subjects design, time becomes a factor. And you will see why momentarily. So remember, between subjects design was where we had separate participants in each group, right? So we tested this group of participants over here, and then in the second group, we tested a completely different group of participants. They were different people, right? Well, a within subjects design is that we are using a single group of participants, and we are testing them in both conditions, or we're getting scores from them in both conditions. So the treatment and the non-treatment, or the 2 different treatments or whatever, they would experience both conditions or both levels of the independent variable. And so you are getting multiple scores from the same people. So that is what the third point here is saying, is that it is often called a repeated measures design because you are measuring the participants repeatedly, right? They are being measured more than once. They're being measured in one condition, and then they are being measured again in a different condition or a different level of the independent variable. So, and that's kind of worded differently in that last bullet point, but it's saying the same thing, right? And so it's not different people in each group, it's the same people. And so there's less subjects involved, which we started, or less participants. We talked about that in one of the other chapters about how that's can be a benefit of the within subjects design, is that you need less participants. So I also did want to point out that we're talking about this as an experimental design, right? An actual experiment where we manipulate the independent variable. In non-experimental designs, they often use within subjects designs as well, but it is different because it's non-experimental, and it is especially used a lot in developmental psychology and developmental studies. And so we will discuss that more in chapter 10, but for this chapter, we're talking specifically about experimental designs where we're manipulating an independent variable. So what this kind of looks like visually, here is the structure of a within subjects design. So you see there's 2 different ways that we can go about doing this. You see we have samples in both, and they're all receiving the same treatment in both A and B, right? But there's two different ways that you can do it within subjects design. The first one is where they receive some kind of a treatment or some kind of manipulation of the independent variable, and then a little bit later, or maybe later that same day, or maybe in a few days or whatever, depending on what the study is and what the variable is, they will be measured in a second condition or a third condition or whatever, but they experience all of the conditions over a certain period of time. The example B down here at the bottom is showing where they're all experiencing all of the conditions at the same time during the same experiment. And so there's some examples of that in your book, but just know that they can experience the treatments all together, all the conditions or all the levels at the same time, or they can experience them in separate chunks. But either way, they are all of our little blue people here are experiencing all of the treatments. Whereas in a between subjects design, if you remember, if we go back to the chapter before, half of those blue people in this bubble would be in one condition and half of those blue people would be in the other condition. And so the other blue people would not experience the other condition that the other blue people did, right? But all of our little people here are experiencing the same thing. So hopefully that visual will help you understand a little bit more about this. So there are two major sources of potential confounding variables or threats to the internal validity for within subjects experiments. There's confounding from environmental variables, and there's confounding from time-related variables. So environmental variables is like things that may change from one treatment condition to another. So things like if they are tested in the morning and then they're tested in the afternoon, or they're tested, and that may be because maybe they were in a better mood in the morning than they were in the afternoon, or it could be that they're hungrier in the afternoon than they are in the morning, or the lighting in the room was different in the morning and the afternoon, and that affected things. But regardless, it's something that changed from one condition to the other for the participants. It's the same participants, but something in the environment changed and that affected their scores. And so because of that, that could be an environmental confounding variable. Time-related variables are things that change between the first and the final measurement that were influenced by factors other than the treatment. Okay, so that's harder to define because there's so many different ones. There's 5 different ones here that we're going to talk about. So these time-related threats, it's things that change between the first and the second measurement when there's time between the first and the second measurement, right? So the first example, or the first type, is the history effect. History is environmental events, things that happen in the world, in their personal life, or even like in the world at large or whatever, but anything that happens that is going to affect those participants' scores. An example that they give in your book is like a power outage on campus. So say they did the first treatment, and then when you brought them back in for the second condition, to test them in the second condition, there was some kind of power outage and it caused a lot of anxiety, and that affected their scores, or a lot of confusion, and that affected their scores, something like that. It's just something it's some kind of an event that is happening in their lives between the conditions, so that they are in a different state of mind, or their scores are different in some way in that second condition, not because of the manipulation of your independent variable, but because of some kind of environmental event, right? Maturation is what it looks like. It has the word mature in it, right? So this is how participants may change or grow over time. This is especially relevant and a cautionary thing to be aware of for studies where there's a long amount of time in between conditions, or whether they're studying these participants over time, and so there may be a long period of time in between testing conditions, and because of that, they may grow or change. Especially the example they give in the book is children. Children, especially young children, change very quickly. Even between, if a month goes by, they may grow and learn and change and have new things, learn new words, colors, whatever that they didn't know before. And so that can be a concern there is maturation. It also talked about elderly, and that's kind of the flip side of that is that their mental capacity may decline over time. But either way, it is a potential problem, because that could be the reason that your scores are different and not your manipulation of the independent variable, not your treatment. The third is instrumentation. This is when there's changes not in the participants, but in the measuring instrument that you're using. So if the instrument somehow changes over time, or the way that it measures is changing over time, that could be a threat to internal validity. The example they gave is this is especially true for behavioral observation measures. So if someone is like observing other people's behavior and writing down things or checking off boxes of things they're observing, if there's some time that passes in between, they may forget how they scored or how they judged certain behaviors. And so they may judge it differently or observe it differently or write different things down or, score differently the second time around than they did the first time around. And it has nothing to do, again, with the independent variable. It was the person, the instrument, right, that was faulty. So that's instrumentation. Regression towards the mean. This is the idea, the statistical phenomenon that after repeated measures, scores tend to go back towards the mean or the average, right? So the idea here is that there's a certain amount of chance and luck involved in everything, in any kind of score, right? And so the example they use is test scores. You may score really high the first time on a test. And part of that is your knowledge, yes, but part of that is also luck. Let's be all honest. We all guess on certain ones that we don't know, the answers to certain questions we don't know. And so you got those right the first time because of luck. But if you were to take that test again, you may score, you're very likely to regress towards the mean, to score lower the second time around, because the chance and the luck, that chance and that luck was in place the first time. It may not be in place the second time. Chances are, no pun intended, that you're not going to have that same amount of luck the second time around. Your knowledge is still there, but the chance may not be, the luck may not be. And so, and this is true the other way too. Say you scored really low the first time. When you are tested the second time or third time or fourth time, you're likely to regress towards the mean and your score is likely to increase, right? Because maybe you had bad luck the first time. The chance was not in your favor the first time. But it very likely will be the second time because it wasn't the first time. And so this is the idea of those stable and unstable factors. Your knowledge base is a stable factor. Chance and luck are unstable factors. They change, right? And so your stable factors will still be there. The knowledge base will still be there. And so that is why it doesn't change a ton, but the chance and the unstable factors change it enough that eventually it's after repeated testing, you are likely going to regress towards the mean. The reason this is a problem is because your scores the second time or third time may change, regressing towards the mean, but that has nothing to do with the manipulation of the independent variable. It's just because they're regressing towards the mean. And so that is something to be aware of, especially if there's multiple testing occasions. Lastly is order effects. These are kind of what it sounds like. It's the fact that you are having something in a certain order, you're testing them in a certain order. So there's different examples here. Practice, fatigue, and carryover. Practice and fatigue are opposites. The practice effect is where they're showing an improvement over time in score because they had practiced the first time. So the first treatment, time they were tested, and then the second time they were tested, they kind of already know what to expect. They have practiced them, and so they're better the second time. It may have nothing to do with your treatment. It may have nothing to do with the independent variable. It could just be practice that causes that. And so that's obviously a threat to internal validity because we don't know if it was the independent variable or not that caused the improvement. Fatigue is the opposite. It is a decline in performance or in scores because they are tired from repeated testing. And then carryover effects is when that experimental treatment is carrying over to the next treatment condition. to the next time they're tested. And the example that they used in the book was a lighting experiment, where scores are, measured because of the different lighting in the room. And so if they are tested in one room with the bright light and they go into the next room and it's a little bit darker, even if it's not that much darker, even if it's a pretty average lit room, it's going to feel a lot darker because they were in the bright condition before. That is a carryover effect. If they had just walked into that room normally, it would have seemed like a normal room to them. But because they were in that bright light condition before, it now seems dark or darker to them. And that's a problem, right? You don't want that, because that's going to affect their scores. And that has nothing to do with the manipulation that you're trying to accomplish. So that specific example is also called a contrast effect because it is the contrast of two different conditions or two different levels of the independent variable. So let's see. Okay, yeah, I wanted to make sure I got all of that. So those are the 5 time-related things. Now, a lot of times these are separated between things that are exclusive to time, the first 4, the history, maturation, instrumentation, and the regression to the mean. And then the order effects are usually considered kind of a little bit of a different, they're usually distinguished as a different thing because it's related to the previous experience in the treatment conditions, not necessarily time. Time's not the only factor. Yes, it is time because they're being tested multiple times, but it has more to do with the experience of the treatment conditions than it does time itself. And so that's why a lot of times those are distinguished. They're called time-related factors and then order effects. Just wanted to point that out. Also wanted to remind you or point out that if this only applies, these threats only apply to the in figure or table 9.1, where it was talking about the 2 different ways you can do within subject experiments. That first, that part A, where you do the treatments, several different treatments over time, that's the threat. That's when these threats are going to be an issue. If they're doing all the treatments at one time all together, these aren't going to be a factor, right? These aren't going to be threats because they're not being tested over time. They're being tested all at once. And so if that is the type of within subjects design they're doing, then these factors, these effects will not be a threat to internal validity. So order effects, going back to order effects, they can produce changes in the scores not caused by the treatments from one treatment condition to another. We kind of already talked about that. Table 9.1, which I'm going to show you in a second, points out, it kind of gives you an example of this, but it also points out 2 very important things. So the first is that the order effect is going to vary systematically with the treatments. So in other words, it's going to contribute to a change in the second treatment, but never the first. So if the first is affected as well as the second treatment, then it is not an order effect. The order effect has to affect the second. And because of that, what they means very systematically is it varies with the independent variable. So the independent variable changed in that second treatment condition, and so did this variable. And so therefore it is a confounding variable, because if it's changing with the independent variable, how do we know whether it was that variable or the independent variable that caused this difference in the scores? So therefore it is a confounding variable and it is a threat to internal validity. Now the group mean, the second point here is that the group mean is going to show a higher score in the second treatment. And that's the problem, right? Because it's going to make it look like your independent variable had an effect, but it may not have. And so here is the table from your book. And what they're showing here is in the 2 columns that have A, those are the original scores with no order effect, right? So treatment condition 1 is the first column, treatment condition 2 is the second column, and there was no order effect here, okay? The mean is the same, the scores are slightly different, but the overall mean is the same, right? So there was no effect. In part B, over here, the last 2 columns on the right, you can see from treatment 1 to treatment 2, there was the scores did change, right? Like you can see the scores did change. But in addition to that, they added 5 to every score because that's the order effect. The order effect is that 5 that they're putting in here, right? And so this is all hypothetical, right? You would not actually add 5 in a real research study. That would happen on its own. The order effect would cause that to happen on its own. You wouldn't actually do this. This is just a hypothetical situation to show you that because there was an order effect, the mean now is 25 over here, and the other one is 20. And so it looks like, wow, look, if we're comparing the 20 and the 25, there was a difference. Woohoo, our independent variable had an effect. The treatment had an effect. When in reality, it may not have had an effect. It's just because of the order effect, right? And so that is where those become a problem. We want to know if it was the order effect or if it was a treatment effect, if the treatment really did have an effect. So hopefully that gives you some insight into within subjects design and into the potential threats to internal validity. We're going to talk about all this a little bit more in the next video. But this is something to think about, a time in your life when you needed to know the length of something but didn't have a way to measure it. And so think about the ways that you measured and cut that piece of paper to a certain size without an actual ruler or tape measure. And then if you found the ruler or tape measure and you were actually able to measure, would the size of the piece of paper have changed? And this is supposed to be getting you to think about the concept of instrumentation changes, like we were talking about, where the researcher who's doing the observations ends up writing down different things or noticing different things the second time around than they did the first time around, because, well, one, that's human nature, but two, if the instrumentation is more subjective, then that's obviously a problem. The more objective your instrument is and your measurement is, the better it's going to be for a situation like this. And that's kind of what this is getting you to think about. Real quick, let's do our learning check. So how many participants would be needed for a within subject experiment comparing 4 different treatment conditions with a total of 20 scores? So hopefully that you know this, that if it's within subjects, then all of the participants are participating in each treatment. And so if there's 20 scores in each treatment, then there's 20 participants, because you're going to have 20 participants in treatment condition 1, 2, 3, and 4. Now, the reason that there is 80 in here is to kind of throw you off, because 20 times 4, right? And some of you may have thought that. There's 4 conditions, there's 20 scores in each condition, so it's going to be 80. But remember, that would be a between subjects design, because there would be 20 different people in each condition, and so you would have 20 plus 20 plus 20 plus 20. But in a within subjects, all 20 people are going to be in every condition. So that's why you only need 20 participants. In a within subjects research study comparing different treatment conditions at different times, what kind of validity is threatened when they change over time, like history and maturation? And so hopefully you know that that is internal validity, right? We've been talking about this whole time. I've been saying internal validity, because it's affecting their scores on the dependent variable, and it is a time-related variable. It is not the independent variable. So that's the threat to internal validity. In a within subject experiment or study that extends over a relatively long time, it is possible there will be systematic changes in their skills or knowledge over time, right? If they influence the participants' scores, so the end of the study scores are different than the beginning because of this, the skills and knowledge changing over time, then what kind of effect is that? And hopefully you realize that's maturation, because they are maturing over time. Okay, so if you guys have any questions about any of this, of course, I'm here